Hey, everybody. Sorry, I'm a little bit late.
Hi, Jim.
I think we can go ahead and get started. Kind of a light agenda today. So if you have any opens, if you want to discuss, let me know.
Well, as usual, if we have time, I would like to talk about workload identity and integration verifier with identity providers.
Sure. Okay. Usama, you said you had some things you want to discuss today. So if you want to go ahead and share
Sure.
or yep.
Yeah, thanks. So, do you want to stop sharing? Then I can.
Yep.
I made a couple of slides, so it would be easier to. Okay. I think this one should be. Okay, so do you see the slide now?
Yeah, I can see it.
Okay, perfect. So, yeah, I have some open questions that I have been thinking for a while, and I wanted to have some opinion of the SIG. Maybe somebody knows. So if nobody knows, then maybe it's something to be discussed on one of the next meetings. So, but I will start by sharing this figure, which is from Azure. Basically, what they are doing is using AMD SEV SNP for as a trusted execution environment. And they have these confidential VMs, which consist of this VM firmware where they have this VTPM. And I want to share my understanding and to learn from the SIG if I'm missing something. But what they are actually doing is this VM firmware is being provided by Microsoft itself. It's not open source. It's not independently reproducible. So I, as an individual, I cannot say with what configuration this VTPM has been configured, what exactly it is measuring. And I would argue that in the very first stage, we are, let's say from my perspective, for example, if I am the user, I'm already trusting blindly what Microsoft is doing here in this block. And if I'm already trusting them, so it doesn't make sense to measure the rest of the things, because then whatever is measured by this VTPM, the OS application is still independent, because it could not be measuring this thing. It could be measuring something else, because I don't know what exactly is inside this VM firmware. And I wanted to ask the SIG basically if I am missing something here, or if I am, yeah. So it's just something that's over my head. How do they claim, or how
So
confidential computing itself is
I
claiming?
have
Yeah.
some questions about that. So if
Yeah.
you remember, in previous discussions, we made a distinction between measurements provided by the CPU of a confidential workload, right? So it could be confidential VM. So effectively hashes of measurements saying, okay, this
So
is what your
it's
TCB is. And
So just Marks, just to be sure. So what here is the workload for you? Is it the VM firmware, UEFI, OS application, or everything?
Well, it may very well be everything. I just want to make sure that we have the
Okay.
right level of discussion here, right? So
Yeah.
there is a quote provided by the CPU of whatever the verifier is going to verify. And there is a separate attestation of the platform by the TPM, and VTPM. I mean, I'm actually the original architect for what virtual TPM does on Microsoft. So I probably know quite a bit about it, but not what they changed in the last 7 years. So we talked about, for instance, the physical location of a workload may be something that you have to trust your cloud provider for, because it's something that TPM attestation would tell you, and you have to trust your cloud provider. Has nothing to do with Intel or AMD. So uh, ultimately, the question, if it's the latter and it's like TPM source measurement, well, you pretty much have to trust Microsoft and have a trust relationship with Microsoft to trust those measurements. If it is the former, so it's a CPU quote over some measurements. So I think that's where your question is really at, because you have to trust at your verifier that VTPM contains nothing untoward, and the firmware is fine. And there is sort of an expected measurement. Microsoft will tell you the expected measurement of this, the hash of that is that, and it's kind of a blind hash. You actually don't know what went in there. And so long as the verifier is happy with that measurement, then you're ultimately saying that the Microsoft is not out of your TCB of the workload itself. Is that correct sort of framing for your question?
It was a long framing, but I will translate this to what I understand and correct me if I'm wrong. So what you are saying is basically that there are two parts, namely the platform attestation of this chip, and then the workload attestation for this workload, namely, as you said, I could think of this workload as the whole VM. So so there are now two parts, platform attestation and workload
Correct,
attestation.
correct.
Right. Okay. So far we are on the same page. So what I'm saying is that platform attestation, I have currently no concerns, and I'm discussing mainly about, and not only mainly, I mean, exclusively about the workload attestation.
And you
Workload
saw
being,
Greg just put a comment into the chat about Microsoft open sourcing some things. So maybe Greg should
okay.
speak. Greg, you have your hand
Okay.
up. Yeah.
I have only one screen, so Greg, please.
Yeah, hi, thanks. I think between Mark and I, we'll get a little more of the Venn diagram kind of stuff covered. But certainly Mark knows a lot of things I don't. My understanding, the part there that's measured in the confidential VM is there's a measurement in the report that has that, and that link I just sent announces that code. I don't know whether it's all the code or a subset of the code, most of the code, but that code is now open sourced. I have no idea about reproducible builds. I wouldn't be surprised if that's not possible at this point. But there's movement in the direction you're concerned about. And that's about as much detail as I could give you there. I think the model that Mark was talking about is kind of the model that folks have here, or is a familiar model to me. One other thing I can share is that an engineer that's working specifically in this technology is on. I'm working with him to come and present to our SIG in the upcoming couple months or so, to speak specifically about how all of this works. And so you'll have an opportunity to talk to the current person in the trenches doing this stuff, and you can ask all the very specific questions there.
Okay, fantastic. That would be great. So to summarize, what you have said is that some piece of code is open source and you're not sure whether that's complete or not. So I believe you are talking about this part. Is this about the
I
VM
don't know
firmware?
whether it's I know for sure, at least my understanding is it's called the HCL, OpenHCL. And my understanding is that for sure it includes the code behind the VTPM. But I wouldn't be surprised if it also includes like the UFI and whatever, what other devices are modeled at this layer here. So, but,
Okay.
yeah.
Okay, sounds good. Then I would be looking forward to the talk of your colleague who will be describing all these things and unpacking it for us.
Yeah, if you look at that
Great.
link that Greg sent, there is a diagram that looks very similar to this, but blows up the VMPL0 with the open HSL blocks.
Mm-hmm.
Also,
Okay.
I will have to say, unless Microsoft changed something since I was there, Microsoft VTPM is a superior design because it actually links endorsements of the virtual TPM with the physical TPM. So there is, in fact, no need to disclose the root key, endorsement key of the VTPM to the cloud provider.
I didn't follow that part. Are you saying that there is a cryptographic binding between this VTPM and the host TPM? Is this correct? The physical TPM?
That is my belief. But when you do the review of the
It's-
code, the open source, you should take a look.
That's specifically what the person I asked the person to come talk about is there's a link between the platform evidence and that VTPM. So basically, the platform evidence in essentially the report data field is going to hash a structure that's going to include essentially capturing the key a couple keys that are TPM based keys. So if that's the link you're talking about,
So
that's
for context, and I see Gary's hand is up, so I'll yield in a second. I first wanted to present on TPM virtualization back in like 2007, and Microsoft basically told me you cannot talk about this stuff at the time, like long story. But TPMs are designed, architected to resist virtualization, right? Because there is this endorsement key, it's supposed to be baked inside the chip, and if you yield the knowledge of the endorsement key to the hosting provider of a virtual machine, well, all bets are off at that point in time. They can get to the endorsement key, then they can sign whatever statements they want. So it's a problem. And I believe with the way VTPM was finally implemented by Microsoft, they're the only implementation that actually does this properly. So, but again, this claim should be checked.
Okay. So is there any other hands up or?
Gary had his hand up.
Yeah, hi. Yeah.
Hello, Gary.
Yeah, can you hear me?
Yes.
Okay, good. Yeah, I'm kind of this, and it's a good thing we have, people like you, Mark and Greg, who kind of have an understanding of this, of the Microsoft approach to this a little bit more, because maybe they answer this. Something that doesn't seem very clear to me is, when I look at this diagram, the measured by VTPM, why wouldn't VM firmware be considered part of the TCB of the workload, and why wouldn't its measurement be included in like one of the designated PCRs like PCR 0 in the VTPM? To me, it seems strange that that the VTPM is only storing measurements at the application layer. And in fact, in general, I don't know if this is included in the open source vision of Microsoft, but it would be kind of interesting to see what exactly is stored in the PCR map for the VTPM, and and whether that actually gets migrated in the context of workload migration. I think another question I had, in anticipation of the upcoming Microsoft presentation is, what does it mean to migrate a VTPM when it's bound to a physical TPM? So hopefully that doesn't need to be answered here, but hopefully that'll be answered in that upcoming presentation. But
I think that
yeah, Mark or Greg, do you know at least what's in the PCR map in the VTPM, and does it get migrated?
there's as far as I know, the VTPM has nothing to do with any physical TPM.
Okay.
The VTPM is basically a standalone TPM, and it can be, there's actually two flavors, I think, under the covers. There's ones that have state that persists between boots, and then there's others that basically start from scratch every time there's a reboot. And they support, I think, different scenarios. And essentially that TPM, that VTPM from an operating system perspective looks just like, a TPM dedicated to like the operating system that boots and runs in that VM. So all the PCR registers you can use it, just like a normal TPM. It supports, the TPM 2.0 interface and all the code in Linux and in Windows that's based on TPM and secure boot, et cetera, runs and records all the normal PCR, measurements and TCG logs, et cetera. And, one of the endpoints in the Microsoft Azure Attestation Service and MAA is basically to take that full stack of evidence, to take the platform evidence for the hosting environment and to take the TCG log and TPM, PCR, quotes, et cetera, and take that as a package and validate it. And part of the validation, it's a composite validation. It starts by validating the platform evidence as a chain back to AMD, does the report data field, basically have data in there that reflects the public key values that are for the EK and AK and the TPM. And if that's true, then we look at the PCRs and the TCG logs and say, okay, this is what we know about secure boot, et cetera, et cetera. And all of that goes, into a token that's returned. I don't know if how much of
That kind of does, but I would contend then, from what you described, that VM firmware can be included in the VTPM measurements
But
in the PCR, and it can get migrated and it can get verified accordingly. So I'd say probably this diagram could be clarified a little bit in that context. So, because the VTPM, as far as I can tell, should work just like a regular TPM, except that it's concentrated on the workload and associated trusted firmware that makes the workload operate in the TE. So,
but isn't
yeah,
Gentry here? But isn't there like a different perspective here that you're sort of stuck? I mean, I shouldn't say it negatively, but you're sort of with CC in general, right? You're sort of stuck having to have a different type of attestation for like microcode, for example. So I think the converse question is also valid too, right? It's like why not have the line for what we do with like the CC specific type attestation be higher, right? Because I think if you look at some of the discussion, I think for this meeting, right, Jim? There's we have to use sort of like TDX attestation to attest the TDX module in the microcode, for example. And then sure, there's a lot of TPM code out there that we want to maintain compatibility with, but the only reason we really are using the TPM metaphor is for that compatibility, right? Not really to claim that we can use it to measure everything.
Yeah, I think my understanding is that there's a VTPM EK, right? So it's layered, and that EK is basically certified by the TEE. So there's a layering there. So the verifier ultimately needs to know how to perform that chain verification.
So Jim, are you saying that this is linked to the host TEE? Is this correct?
Yep.
So is it?
Yeah, and that's what I said when I was explaining how the that's what I said when I was explaining how the chaining worked. Like the attestation evidence for the host layer, be it TDX VM or SysMP, is going to have a measurement of that part on the left that says the VM report on the left, the UFI and the VM firmware and the VTPM. It's got a measurement
So
of
Greg,
that. Yeah.
So Greg, my understanding of what you said was that there is a cryptographic binding between the physical TPM somewhere over here and the VTPM.
No, there's
Well, yeah,
no
Mark
physical
Mark Novak
TPM.
said that. Mark, is that true? Is it
So
rooted in the physical
me-
TPM, or is it rooted in
No,
the
it's not.
TCP?
let me clarify what I said.
Okay.
So in order to place trust in a TPM, virtual or physical, you need to place trust in the endorsement key of the TPM. Whoever has access to endorsement key of the TPM is basically the entity that you're trusting. Right. So for instance, if the VTPM endorsement key is under the control of your cloud services provider, virtual TPM attestation is only as good as your trust in the cloud services provider. Right. Okay. Now, to speak to the question that was posed earlier around, don't you need to trust whatever TPM says inside of its PCRs? Well, before you launch the whole thing, you measured the stuff that goes into the VM that the VTPM is going to be measuring. So you would be double measuring it at that point in time. So you have to trust the hardware for whatever code went into the confidential VM, including VM firmware, including VTPM, and then the trust in VTPM measurements at that point in time is transitive, and you're not sending that to your verifier, hopefully, because that is double measurement or transitive trust.
Well, I was talking specifically in the context of workload migration, and that could be interplatform.
In case, all right. So in case of your workload migration, you once again need to think about the ownership of the endorsement key of the VTPM. So if you migrate to another device and your endorsement key is transitioned with other data that is subject to data and use protection to the other device, well, your VTPM endorsement key has not changed and your VTPM endorsement certificate has not changed, right? Then the question then becomes, again, who signed the VTPM endorsement key and who knows that VTPM endorsement key? And it could be that your VTPM endorsement key is signed by the host, and the signature will change. I don't know if that's a good idea or not. And again, I guess I need to relax my previous statement, but the way I believe that VTPM thing was architected was you did not need to trust, like it was possible to create VTPM in such a way that the cloud service provider was spared the knowledge of the VTPM endorsement key. And I think only presentation from Microsoft can clear that up.
So I think, Mark, you made 2 points. I like that kind of segregation, that who knows endorsement key and who signs endorsement key, right? So both these parties are trusted. I like that statement. That kinds of sum up everything we need for the purpose of understanding who is trusted, like in these 2 categories. And I would say if this piece of code itself, which includes this VTPM, the VM firmware code, is not open source, then at least we don't have any idea of the endorsement key. And I believe then the CSP is actually doing all of that for us, putting in some code and which includes the ownership of the endorsement key. And who signs that is also not clear to us, that who is signing that, maybe the CSP itself. And that's what I mean by open source and independently reproducible, that we can check actually what is going on. And I very much like these 2 points that bring us more formalized statement of saying who is trusted in this case. And coming back to another point that was made about the persistence of the state of VTPM and its migration. I think that was the point by Giri. I am still a bit confused about if you have it strongly bound to this host, how would it then be possible to migrate it, and all the context, especially
Well, it's
if
just a
it,
trusted execution environment. Why wouldn't you be able to migrate a trusted execution environment from one host to another while preserving all its secrets? Like you need API for workload migration, like you get on AMD, but there is nothing special about VTPM that precludes migration. All you need to do is migrate the endorsement private key securely to your target.
okay, so
I think Jack has his hands up from quite some time. Maybe we should give him chance to speak and ask his question.
sure, please go ahead.
Thank you. I originally wanted to focus a little bit on the point Mark mentioned about how the EK of the VPN is in some way connected to the hardware, but I think Mark clarified that. The second thing that I wanted to talk about or a little bit mention is the endorsement key and who provides it, because that becomes the identity of that TPM. In this
So,
context,
Jag, so when you say who provides, that means basically what Mark said as who knows, the ownership of the endorsement key, right? Is it correct?
yes. So, for
Okay.
example, in a TPM, the manufacturer of the TPM supplies the
Mhm.
endorsement key. So
Right.
we can verify the EK or anything that the EK signs using the root key from the manufacturer. But in the case of a VTPM, I was having the same problem. If it's the cloud provider that provides the EK,
Mhm.
we cannot trust that. And I was talking to a TPM expert in FOSDEM, and he was mentioning about a different process that was involving a CSR, where the only thing that we need is secrecy of the AK, the attestation key. So the process involves generating a key pair inside the TPM, and then the TPM has to demonstrate proof of possession of the private key to the CA, and then the CA will issue the certificate, a signing certificate for the TPM, which we will have to provide to the TPM. And the
So
TPM,
Jag, just to be clear, so the key that the TPM is generating, is that are you talking about the identity key, the AIK, attestation identity key? Is it that, or is it something else?
it is the attestation key. It's not just the identity key. It is used for signing the quotes also.
Okay, the signing key. Okay, so it generates its attestation key and asks the CA to do its verification.
Asks the CA to provide the attestation key. So the CA will then generate attestation key, and it will return it. The user can't see it because it will be encrypted.
Wait, sorry, I'm a bit lost. So first you said it generates a key pair within itself, and then you said that the CA generates the key and gives it back. So are there two different keys, or are we still talking about, or are there two different ways of doing that?
You are correct. There are two different keys.
Okay, so
Then
which one is which is the one which is generated within the VTPM? Which precisely in TPM terminology, which one is it?
Okay, so the first set of keys that we create with TPM is just a generic signing key from the TPM. Okay, it has no label as far as the industry is concerned.
Okay, so this one is not the attestation key.
It is not the attestation key. The sole purpose
Okay.
of initial keys we generate is for the CSR to demonstrate
Okay.
possession. The CA will generate the attestation key, and so the CA will generate the attestation key so that whenever TPM quotes are generated, we can verify the signature and trace it back to the CA instead of the endorsement key. That is the concept. I can share some details, but the reason why I brought this up was, is anyone else doing this, or if there is a different or a recommended way to provision. This is, I think it's called credential activation step to perform this in VTPM. That's my question.
So I'm not familiar of anyone doing it, but I can share some understanding of the attested CSR that I have is a bit different from what you explained. I'm not sure how much, maybe there might be a misunderstanding between you and the person you were talking at FOSDEM, but so my understanding is that the way attested CSR happens is you generate a key pair, which is, as you mentioned, is correct, but it's not the CA that generates the attestation key. So it just sends over the proof of possession of the key that it generated. And the attested CSR basically attests that this one is in the correct form. So that basically CA acts as your verifier and it sends over back the attestation results. And with these attestation results, you do then the handshake or whatever you want to do. So you basically change the model. You do it in the passport model form. That's my understanding, which basically contradicts your understanding when you said that the attestation key is generated by the CA, which I don't believe is correct.
I think the flow usually works with that the proof of possession is demonstrated by the requester, and once the proof of possession is established, the CA would sign the public key associated to the attestation key, which I think Jag is referring to, and he would issue a certificate.
No. He said that the CA is actually
Yeah. I mean,
itself
I don't think that
generating.
could be. Yeah, I don't think CAs generate keys, but they certify the keys. So the public part is certified, and then that is used by the for the verification. That's how typically it works. But maybe
Right.
we need to
And
we need to check the credential activation step, what he mentioned. Yeah.
And even then, that's not the attestation key. That's a separate key. That's what we call as the ephemeral key. So that's the ephemeral key that it generates, sends over, gets the certification. So I'm not sure. So I will check the reference that you are mentioning that, but maybe somebody
Greg has
else
his
knows.
hand up.
Sure, please go ahead.
I may cause more questions than have answers, but I think part of what I was hearing here was discussing how a CA via some sort of CSR conversation may basically return a cert chain for an AK up to a trusted root CA kind of thing. Is that kind of the conversation I was hearing?
Yes.
So in the VTPMs in Azure, such a thing exists, and basically, but I'm not the expert. I'm in terms of exactly how that's done, exactly how that's intended to be used. I just want to say that's part of the infrastructure under the covers, and Mark may know, but when this other person,
Well, my knowledge is 7 years stale, so I really, I remember worrying about it at the time when I designed the VTPM, but that was also at the time of VSM and before we had trust execution environment. So that was again, things probably changed a bit.
I'm giving you carte blanche to jump in over me anytime and say wrong, right, etc.
I think actually every CSP owes us an explanation of how the VTPM key is secured, right? Because if we simply need to know, right? If we need to trust whatever VTPM says for the PCRs in attesting or in whatever VTPM is used for, then for purposes of understanding and accepting risk, customers deserve to know.
Mm-hmm.
Like it's not just to say I don't trust it. Like I may choose to trust it, but I need to know.
Mm-hmm. Yeah, I'm not familiar enough with the. Yeah.
Yeah, how would you say that the endorsement key has to be cryptographically linked to the hardware root of trust? Now, what your hardware root of trust is, whether it's a hardware TPM or it's going to be a TEE, it still needs to be linked. And even in the case of a CSR, right, the CSR would have to be signed by that hardware root of trust in order to get the certificate back. Or you could just include the endorsement in the chain, right?
Yeah.
So you either get request a certificate for the key pair, or you just attach the root of trust.
Well, like the entire root of trust of the VM. This is not just VTPM. The entire like set of roots of trust in your VM, including your certificate store, your AIK, EK, like all of that needs to come from somewhere. Unless your image is encrypted when you launch it in the cloud, the content of that image are public. This is why I was worrying about it when I was designing VTPM. I was like, you're going to deploy this image, you're going to say it's confidential. Where does the endorsement key come from? You certainly can't store it in the image, because the images tend to be public, right? So when you're launching your VM, you need to understand where that secret is coming from.
Yeah, and in the TDX TEE, I know that the EK gets a quote, right? It asks the attestation of TDX to sign it. When it's hashed and whatever else material it has.
I think, Jim, there are two separate concerns. Let me try to maybe, or at least in my mind, these are two separate issues. One is what is the cryptographic binding between the endorsement key and the root of trust, let's say in this case, the AMD SAV-SNP. But I very much like the point that Mark made. I mean, there could be still some cryptographic link, but if the provider of this, if CSP knows this endorsement key, AMD doesn't know that. So AMD, the job is just to sign that. It's given something to sign. It's just signing. It's protected within this confidential VM. Fair enough. That's everything is good. But this, I mean, this cryptographic binding tells you nothing other than saying that it is cryptographically protected.
Well, I mean, the measurements of that VM, right, has to be in there, right? It's not just signing; it's saying these are the measurements of this piece, right? So that's what's in there.
Sure. So there comes my point of open source and independently reproducible. If I don't have this piece of code, the measurement, what would I do if Microsoft gives me measurement of this is this piece of code is XYZ. AMD will just sign that. I as a customer will say, okay, Microsoft is saying me the reference value is XYZ. Fair enough. But that still adds Microsoft in the loop of trust chain, which is namely, I as a customer, I am trusting Microsoft that this XYZ was as I want it to be, but I don't know. That's my point.
I think that's what Greg was alluding to, that, right, this is all open source software, and you could, hopefully they support a reproducible build, so you could actually recreate that image yourself from the source and compare the measurements that they're saying it is and what you are able to verify independently.
Okay. Yeah. So he as per my understanding, at least he said he's not sure that everything is open source, but hopefully it should be. So that's my point. So as a summary, what I wanted to say was that there are two separate dimensions in case something is not open source. One, namely, what's the cryptographic binding of this thing with the root of trust? And second one, who is the kind of provider, or who is the owner, as Mark called it, and who signs this endorsement key? These are important questions from trust assumptions perspective that we bring in, independent of the root of trust. That's something that's the provider of that thing. And the whole thing colludes when actually Microsoft itself is doing the verification. And I don't accept that model. But to me, it's my adversary saying me, hey, everything is good. But yeah, the verifier should be independent of the CSP for sure. That's something we need to work on. So any other thoughts on this before we proceed to discussion time.
Yeah, I got my hand up, so I'll just mention another
Sure,
thing.
sure. Sorry,
Um,
I can't see the hands up. I have only one
yeah,
screen, so
no problem. I'm just saying, I'm just justifying it as to why I'm interjecting here. There is another thing too, I think, as we delve further into the VTPM that I'd like to get a better understanding on, and maybe Greg, you can see if it can be discussed when Microsoft's ready to do that presentation, and that is how is if there are for want of a better terminology, if there's like trusted IO extensions to the confidential VM, like for instance, devices that are memory mapped to the confidential VM, maybe communicate, reachable over a PCIe interface, as an example. Is that actually reflected as far in the VTPM binding, or is that something that the platform maintains in the Microsoft vision? And then to even further extend it, what does that mean in the context of workload migration? Because it may not always be possible to migrate physical device extensions to the confidential VM memory map. So as an example, ARM confidential compute architecture has something called realm management extensions. And if you look at that during runtime, a VM can actually have its memory map extended to include a physically attached device for whatever reason. So it needs to do that, and that physically attached device should be platform attestable. But I'm not clear whether it needs to be VTPM attestable or not. If it's not clear what I'm asking for, I can try to rephrase.
I'm not an expert in this stuff. I mostly work on scalable cloud services and think about things like, global deployments and things like that.
Okay.
I think that I think one thing is I think the person I'm organizing to come and speak to the group, I think he probably would be able to answer that question. From my perspective, kind of where I see activity about TPM-based measurements are for devices that are participating, that very specifically are participating, that are, I'll call them confidential compute enabled, right?
Okay.
So any device that's basically has confidential compute capabilities, perhaps a confidential GPU or things like that. It's like, how does this get reflected in the attestation evidence for essentially a VM, a confidential VM running in Azure or a cloud vendor's CSP environment? That's the kind of activity I see and being thought about. And
Yes.
from what I see, that's all kind of being invented on the fly, and people asking questions like, what should the standard be? Are there any standards? That's what I'm seeing. As for like just other devices that are just part of a VM and where they appear in TPM evidence, if at all, that's not something I have knowledge of. I've not heard conversations.
Well, when I'm talking about other devices, I'm thinking about the GPU case in particular. So I mean, if you start with that, I think the model extends pretty in my opinion, is the model will extend pretty seamlessly to other devices that could be memory mapped. So
if you're
I mean,
talking about
yeah.
you are talking about the GPUs, I have a slide on that, so I will quickly go to that. So this one is actually about the GPU.
Before we get into this, let's do a time check on the topic. I know we got less than 15 minutes left.
Okay, so you want me to stop?
Well, maybe we could, if we I don't want saying we stop, but I don't know how long this discussion is. But if we summarize it, is it the question about how do we handle migration with confidential VMs?
Wait, before we jump there, I'm dying to make, based on the last 30 seconds, I'm dying to make one more request or statement. And that is if if any, from what I can tell, it's kind of the wild, wild west in terms of figuring out how to do something like take a confidential GPU and make its attestation evidence work well with TPM-based confidential VMs in the cloud environment. And I've not seen any sort of, not that I've looked, but tremendously, but I'm not aware of any kind of standards or discussions going on in that vein. If anyone's aware of some or wants to get some going, I don't even know if we're ready for that in terms of maturity of what's going on.
So let me pose like a really important question from a customer's perspective in this context of this. So when it comes to migration and VTPM, I will basically repeat what I said. So long as you can move your workload and protect all its secrets, VTPM or not, actually doesn't matter. Then you are fine. You know, there is a separate question of how do you provision these secrets securely from how you migrate them securely. Once provisioned, if migration is secure, then all you did, you moved from one host to another, don't disclose anything. However, and this is where most of my interest really lies, what I really want to discuss in this SIG is we do need to combine attestation of the workload with the attestation of the platform. Attestation of the platform is necessarily something that's TPM-based, where we trust our cloud service provider for the claims. Now, if the claim of importance about the platform to me as a customer is data sovereignty and that the workload is in Germany, then when that migration happens, even if the secrets inside the workload are perfectly protected, but the workload got migrated to identical hardware, but in France, then we got a problem, a data sovereignty problem. And when that migration happens, I need to understand how the workload claims, and this is in the context of workload identity and this other SIG that I'm sharing, how do we ensure that the workload claims retain their veracity in that process? Right? The claims about the workload are not going to change in the migration, but the claims about the platform very well might. And we need to understand how to either prevent an invalid migration or detect an invalid migration.
But I think that's easier said than done. So it's a lot of things that need to be taken care of, which you can sum up in saying that, okay, it doesn't matter which host it runs on, and it can just be migrated as long as it is secure, but that entails a lot of stuff in itself. That how does that
saying it's
actually
difficult is not a good answer. Right. So again, let's start by decomposing the problem, right? So your attestation is now twofold. You attest your workload and you attest your platform. You attest your workload using RATS verifier, and you attest your platform using TCG and TPM. And then
RATS alone doesn't do anything. You need
to figure out the binding between them to make sure that I'm not attesting the workload of one on one hardware and the platform of another. That would be a security hole. And then we need to figure out how to ensure that the migration process itself does not alter the claims in a way that it's no longer acceptable to the customer. Like that, all of that needs to be figured out. Otherwise, we cannot do data sovereignty, and it's a big adoption hurdle.
Yeah,
Lachlan, you had a comment?
Yeah, I mean, I also kind of had a question here. I mean, you're talking a lot about, or people were talking a lot about confidentiality with respect to the migration, but what about other sort of more distributed systems-y issues? Like, for example, for a while, I've been trying to work out how to do kind of good atomic migration in this case. And as far as I can tell, this hasn't really been solved, but maybe other people can kind of contradict me on this. But it seems like with things like VTPMs and with TEEs in general, there is this problem that you also have not just confidentiality to deal with, but stuff like non-duplication. Because let's say you've got some monotonic counter somewhere. Well, you want to make sure that there's only one copy of that so that it can't be rolled back.
Sounds it's even more complicated than I made it sound. We should probably start compiling these concerns and then start addressing them.
Yeah, I think that's a good idea. I talked about the data sovereignty point that you raised, Mark. So that's something which absolutely requires a trust in the host. So I think the way forward I see is number one, to distinguish about what we trust the host for, and then number two, to see all the issues with that kind of trust. What can we minimize? What kind of trust we can minimize actually, from a technical
Well,
perspective.
I would not even say minimize it. You just need to be contained, right? So I need to know who I'm trusting for what, and that's a perfectly, fine thing to do. But this is, I said it before, people I trust with my children and people I trust with my money. They're different sets of people, and that's perfectly okay. So long as the two shall never mix.
Yeah, that's also fine. From technical perspective, we want to maybe minimize it, but yeah, I agree with you. Like in principle, I'm fine with saying that at least we know who we trust, rather than saying that, hey, this is a complicated set of technology, and you don't need to trust the CSP at all, which is completely wrong. And Greg also talked about people asking him for standards, and we are, from a standardization perspective, in attest-TLS stuck on exactly this thing, which is namely for confidential computing use case, the attest-TLS. How do we provide that? We actually satisfying this model. How do we satisfy all the guarantees of attestation, of TLS, and the composition of both? That's impossible within this threat model. So yeah, it really needs to be segregated down in order for the standardization work to proceed.
Yep, it's a great discussion. I think really this is a separate sort of migration topic that needs more discussion, aside from just trusting the
And
static.
also just
PM.
let's just start before migration. Let's just start with one thing. How
Yeah.
can I know? How can I combine platform attestation with workload attestation, and make
Right.
sure
I
that
think-
I did not just attest two different things?
Yep.
Right. We
Yep.
need that, and we need Microsoft and Google and the rest of them to ensure that this guidance is followed.
Yeah, agree.
But Mark, that already is, at least the conceptual model is already there by ARM. So they have the platform attester and the workload attester, and there is a binding between the two. I don't think that's an unsolved
If
problem.
it's been
at
worked
least
out,
for-
I'd love to review it, and I also want to understand what happens on AMD and Intel, because
Okay.
we're dealing with all of these.
Yeah, sure.
But yeah, if you have a link to the ARMS solution to that, you might want to share it with the mailing list. Like, I'd love to personally read it.
Yeah, sure. So we actually, that was one of the SIG project itself, where we had ARM CCK remote attestation. So Thomas Fossati, Simon Frost, and Shale, we worked together. So I will share that on the list.
Okay, we got 5 minutes left. I probably don't have much time, Mark, to discuss the workload identity. But we did have another topic here that Thomas wanted to, and the chairs to make everybody aware of a document for composite attesters. There's a couple of issues that are also related to it, and basically just let everybody know about this and ask for contributions. So if you have some time, take a look at that.
Yeah,
Thomas,
all
I don't know
requests
if
you
you
have,
have.
please put them in email on the mailing list. I don't recall seeing a request like that on the mailing list. Maybe I missed it.
I think I sent mailing list, Mark. I will rebounce it if needed, but it should be there already.
Well, either meeting minutes or the mailing list, like something that persists that I can go back and look at.
That's there. On the attestation mailing link, composite attester doc is the subject.
Oh, okay. I recall seeing it. It was kind of a draft, like sort of an seed document.
Yeah,
Yeah,
this
Yeah, so it doesn't really have like content for reviewing. It's more like starting the conversation.
exactly.
Yeah.
In particular, if you have specific knowledge on one of the topics that are highlighted there, and you want to contribute the whole section, then it would be awesome.
So we're submitting from the Trustworthy Workload Identity SIG, we're submitting an informational draft to ITF for Madrid. And we're basically saying there are three issues that we need addressed. One is lack of workload isolation. Okay, fine. The other one is like lack of stroke binding between credential and the workload instance. Fine. The third one is we're basically saying there is lack in today's Windows workload identity ecosystem. There is a lack of what we call verifiable composition of the workload. So that's kind of the phrase. We just came up with it today, actually. And the verifiable composition of the workload means that a verifier needs to be a part of the workload credential issuance mechanism. So it's not just the identity provider, and a verifier needs to be in there. We need to figure out all ways by which that can happen. And also the composition of the workload. So there are a couple of angles to that. One is, okay, what's your bill of materials, and what did your CI/CD pipeline say? Like, how was it composed? Like, what is it made of? And also, the other part of composition of a workload is if it runs on multiple Ts. So now there's my SmartNIC and my CPU and my GPU, and when I attest them, I'm attesting the entire workload running, how it's composed. And there is even a third one where my workload might be composed of multiple, building blocks running on different devices. Like I'm prepared, I'm afraid to even go there just yet. But verifiable composition will be sort of the umbrella under which all of these issues need to be discussed and solved.
Yeah, and Mark, for that, there's a specific section that I opened on the document, right? And I'd like to have your input on there because yes,
absolutely,
to build to have the building blocks for that, for treating that as in the ref value world, right? So that the verifier can be trusted with the idea of the composition that is expected. But that needs to match also with the shape of the attestation evidence and the shape of the attestation results. The three ingredients need to match in order to make sure that what the device provides and in terms of security properties to the workload bundled with the workload and bundled with any trusted device that should come in the TCB picture is something that is well represented and can be assessed by the verifier against a set of well-defined reference values that exactly depict the topology of what is that you want to be sure that you are appraising.
I'm super interested in this topic. I also need to drop for another meeting, so I'll see you guys later.
Okay.
All right. Thanks, everybody.
Cheers. Jim, next time, who's chairing?
Yeah, I didn't put it on here because perhaps we're having those chair meetings, but
I think I'm
I
next
don't
in
know.
line.
You're
Okay.
next. Okay, so I'll put you down here.
Cheers, guys. Thank you very much.
Yep,
All right.
thanks.
Thanks all.